Hello everyone, welcome to this video. In this video let's look at another example of group. So here I am considering the group of Z4, right? It contains these four elements 0, 1, 2 and 3. So according to this 4 we have up to 3, starting from 0 up to 3 the elements, right? And the operation that we use here is addition modulo 4. So remember we have studied about modular arithmetic, so we will make use of that concept here. And what does this mean? This symbol mean that if you apply it to two different numbers, say A and B, so what you are doing, you are actually adding these two numbers and then taking mod 4 of it. So whatever is the answer, that is your answer, right? So whatever is the remainder obtained after adding A plus B, that is your answer, right? So now we need to check whether this set together with this operation does it form a group or not, right? So for that, because here we have finite number of elements present in our group, so therefore we can construct Cayley table for it. What is that Cayley table? Here we write all the elements of the group 0, 1, 2, 3. Here also we write all the elements of the group, and here we write the operation which is addition modulo 4, right? Now what we'll do, we'll fill up all these columns, all these boxes one by one. So what are the digits here, that we have to check. So basically we need to solve each of these things. So how we can solve it? So for that, for the first entry here, what we'll do, it corresponds to this and this. So basically we will perform 0 plus addition modulo 4, 0. So that means 0 plus 0 mod 4. So what is this? It is 0 mod 4. And what is 0 mod 4? When you divide 0 by 4, the remainder you will obtain is 0. So the answer here is 0, right? Now next, corresponding to another entry, say here we wanted to see what will come here. So it would be 0 addition modulo 4, 1. So it would be 0 plus 1 mod 4. So what would be this? It would be 1 mod 4. When you divide 1 by 4, the remainder that you are going to get is 1. So here the answer is 1. Similarly, for the next term, we wanted to calculate, say this digit. So it would corresponds to the 0 and 2. So it would be 0 addition modulo 4, 2. So it would be 0 plus 2 mod 4. So it is 2 mod 4. So basically the remainder that we obtain is equal to 2, right? Similarly for the other cases as well, suppose similarly you can calculate this 3. Now suppose you wanted to calculate say this digit here, right? How do you calculate this? It corresponds to this digit and to this digit. So it would be 2 addition modulo 4, 3. So this is equal to 2 plus 3 times of mod 4. Now what is that? It is 5 mod 4. So now when you divide 5 by 4, you will get the remainder as equal to 1. So your answer is equal to 1 in this particular case, right? So you can fill this table according to this banner, and once you have this Cayley table, now looking at all the properties of group is very easy. So now notice here that all the elements that we have filled, we have filled here, right? They are either of 0, 1, 2 or 3. Nothing apart from them is written in this particular table, right? So closure property, it says that when you apply this operation on the elements of the given set, then the result should also belong to this set. So in this case the result is just either 1 or 2 or 3 or 4 in every of the either 0 or 1 or 2 or 3. So that means all the elements that we obtain as the result are member of this set only. So therefore the closure property hold in this case. Next is the property of associativity. So in associativity, we need to check that when we apply addition modulo 4 onto A and B and then apply it onto C, the resultant would be same as when we apply it first on B and C and then on C, right? So this operation is associative. So for an example, I have took these three numbers, say 1, 2 and 3. So first of all, I am applying this addition modulo 4 onto 0 and 1. So 0 plus 1 is 1. 1 mod 4 is how much? 1, right? And then 1 addition modulo 4 2. So it is 1 plus 2, that is 3. 3 mod 4, that is 3 only. And next, for the next term, we first of all wanted to solve this one portion. So 1 plus 2, that is 3 here. So 3 mod 4 is 3 only. And then 0 addition modulo 4 3, it is equal to 0 plus 3. So it is equal to 3, right? So this is about associativity. It is associative and you can check it for every pair, although checking it is quite difficult. However, let me tell you that this operation is associative in nature. Why? Because we are just adding two numbers and then taking their mod. So you know addition is associative, so therefore this operation is also associative. Next we'll be checking for the identity of the group. So here if I suppose take any element A, any random element, and call it as A from the given set, so that means A could either be 0, A could either be 1, A could be 2, A could be 3, right? So from these four choices of A, we need to find an element E which is a member of Z4. So what does this E represent? It represents the identity of the group, such that when you take the element and that element's addition modulo 4, you will get back the same element from which you have started, right? So this is quite easily obtained from the table. From the table you just have to see that corresponding to which number are we getting this same row. So you see we have this as the same row and it corresponds to the number 0. So therefore 0 becomes our identity, and this could also be checked via this column wise. So you have to check whether which number corresponds to the same sequence. So here this is the same sequence, right? And so therefore it also corresponds to 0. So therefore 0 acts as the identity for this particular group. So we obtain E as 0 in this particular case by looking at the Cayley table. And lastly, we need to find the inverse of each of the elements here. So we are looking for some number B such that when we apply A addition modulo 4b, we obtain E, which is the identity of the group. And what is E? E is equal to 0 in this particular case, right? So here in this case we are looking for numbers such that for 0 we are looking for 0 plus addition modulo 4 what number, so that it is equal to 0. Here in this case we are looking for 1 addition modulo 4 which number it is equal to 0. Here we are looking for some number such that it is equal to 0, and here also it is like this. So we need to fill in these blanks through the use of the Cayley table. Now for 0 we need to see for which number we obtain the result as 0. So this is 0. We obtain the result as 0 for the number 0. So that means the inverse of 0 is 0 only, correct? Now for the second term here, we wanted to see for 1 which number give us 0. For 1 which number give us 0. So 0 is the result, so number 3 give us 0, right? So the inverse of 1 is 3. Similarly the inverse of 2, so we need to look for 2 such that the result is 0. Result is 0 here. It corresponds to 2 only. So that means the 2 is the inverse of 2. And for the last one we need to check what is the inverse of 3. So we are looking for 3 such that we obtain a 0 in the final answer. So it corresponds to 1. So 3 is the inverse of 1. So we have inverse of all of the elements in this set, right? So therefore all the 4 properties are satisfied. So Z4 is under addition modulo 4 is a group, right? And in addition to this it is an abelian group. Why? Because we also have commutativity present in this particular group, right? Because we have A addition modulo 4b, that is equal to B addition modulo 4a. There is no difference in this, right? And moreover we also have this result that for any for a set Zn which consists of all the numbers starting from 0, 1, 2 and up to n minus 1, right? This index minus 1, whenever n is either equal to 1 or it is greater than 1, and the operation here is addition modulo n. So this forms a group. This is the standard result. You can take n to be any number which is greater than or equal to 1. So this group is called the group of integers modulo n, right? And for this group, particular group here, when we have j as greater than 0 present in the set of integers, the inverse of j exists and it is equal to n minus j, right? So this is the result and this is the example corresponding to group. Well, that is it for this video. Thank you for watching.